Now it's not only whole numbers that can be squared or cubed or raised to some other power. Fractional numbers can also. So for example, if we want, we can square 2.5. Now what is 2.5? Well, as we dealt with fractions a little earlier, how many halves is that? How many halves in 2? Well, 2 halves in 1, therefore in 2 there must be 4 halves, and then we have another half to add on, so that's 5 halves, which is to say 5 divided by 2. And you remember how we do that? We put 5 and then we divide by 2, and then we put a decimal point here, and we can string out some zeros to the right of that decimal point. Let's put the decimal point up there. 2 goes into 5 how many times? 2 times. What are 2 2's? Well, there are 4. So we subtract 4 from 5 and we get 1 to carry down, and then we bring down the 0. 2 into 10, how many does that go? Well, 2 5's are 10. So we put it up here just to the right. And then how many are 2 5's? They are 10. What's the difference? There is none. So we're done. So 2.5, another way of expressing that in what we described earlier as fractional notation, is 2.5. Now we can raise 2.5 to the power of, for example, 2. What is 2.5 squared? Well, it's 2.5, just in the same way that 2 squared is 2 times 2. So 2.5 squared is 2.5 multiplied by 2.5. And we can do the arithmetic, the multiplication as we previously did, and we can see that it comes out equal to 6.25. So 2.5 squared is 6.25. Now let me just change colors again. Now in addition to raising fractional numbers to various powers, we can raise any number, whether fractional or whole numbers, to fractional powers. We can raise 2 to, for example, the power of, what shall we say, 1.5. How many halves is that? That is 2 halves go into 1 plus 1 additional half. That's 3 halves. 3 over 2. Now if we were to see something like that, 2 to the power of 3 over 2, what on earth would that mean? How can we raise something to 3 over 2? Because we remember that we write down for 2 squared is simply 2 times 2. 2 occurrences of 2, and then we multiply them together. But here we have 1.5 occurrences of 2. How on earth are we going to do that? 1 times, maybe it's something like this, just a half an occurrence of 2, with the other half lopped off. Now I'm only joking. What on earth are we to make of that? Well, in order to see what we're to make of that, let's just consider first of all, for example, the number 4 to the power of a half. Now any number squared, is what we said, we mentioned this a little bit earlier, is just we multiply the powers together to get that. So what's 4 to the power of a half, whatever that might be, squared? How do we, what is it? We multiply a half by 2. What is a half of 2? It's 1. That's 4 to the power of 1. And what is 4 to the power of 1? Well, it is 1 occurrence of 4. It's just 4. Any number raised to the power of 1 is just itself. It's just 1 occurrence of itself. So what we know here is that 4 to the power of a half times 4 to the power of a half is equal to 4 to the power of 1, which is just 4. And indeed, by what we said when we were talking about logarithms, that is absolutely clear, because 4 to the power of a half multiplied by 4 to the power of a half, we add in that case when we have the same base. In each case, this is 4, these two together. So that is 4 to the power of 1. So 4 to the power of a half is whatever number, when multiplied by itself, gives 4. Now what's another way of expressing that? Well, we've just done it. It is the square root of 4. So 4 to the power of a half is, again, the number which multiplied by itself gives 4, and that number we've already defined as, another way of expressing it is to say it's the square root of 4. And what is the square root of 4? Well, it's 2, because 2 multiplied by itself is equal to 4. So what do we have? Let me just change color. We have, quite simply, is that 4 to the power of a half is equal to the square root of 4, which is equal to 2. Now we can generalize this and say that 4 to the power of 1 over any number x is simply the xth root of 4. And we can generalize it even further, and we can say that for any number y, not just 4, if we raise it to the power of 1 divided by x, that is just another way of writing the xth root of the number y. So again, whenever we see a number and raised to a fractional power 1 over something, it just means the something root of that number. What is 9 to the power of a half? Well, it is the square root of 9, which is to say the number which multiplied by itself equals 9. And what number multiplied by itself equals 9? Well, 3 does. 3 times 3 is 9. Now, interestingly, what about when we see something like this? 9 to the power of 1.5, and 1.5 is 3 over 2. What is that? Well, again, it follows, we can work it out from what we've said so far, because 9 to the power of 3 over 2 is 9 to the power of 1 multiplied by 9 to the power of a half. Because remember, when we're multiplying, we have the same bases here as in our little video which ended with a description of logarithms. We add these powers together. So adding 1 to a half, we get 1.5, which is to say 3 divided by 2, which is what we have over here. Now what is 9 to the power of 1? Well, as we set up here in the case of 4, it is simply 9. And what is 9 to the power of a half? Well, as we've said over here, it is the square root of 9, which is 3. So 9 to the power of 3 over 2, 1.5 that is equal to 9 times 3. And what are 9 lots of 3? Well, they are 27. Now another way of expressing this is simply to say that 9 to the power of 3 over 2 is equal to the square root of 9 cubed. And let's see what the square root of 9 cubed is. Well, 9 cubed is, let me just go down here, and perhaps I'll just change color to make that a little more visible. That's the square root of 9 times 9 times 9. The square root of 9 times 9 times 9, and that is equal to the square root of 9 times the square root of 9 times the square root of 9, which is 3, well, that's a square root, which is 3 times 3 times 3, 3 times 3 is 9, times 3 is 27. So actually I'll cross that out and put 27. And indeed that's right, we have 27 there and 27 there. So the message is, just don't get confused or daunted when it comes to numbers raised to fractional powers. So we can raise any number, any base as we describe it sometimes, to any power, whether that base or the power be fractional or a decimal, because any decimal number, just in the way that fractions can be expressed as decimals, so decimals can be expressed as fractions. Let's suppose I had 2.2 raised to the power of 1.6. That's a number, and I can work out what number that is. As a matter of fact, what does that number work out at? Well, it is roughly 3.53. That is just over 3.5. Now, I actually worked out what 2.2 raised to the power of 1.6 happens to be on a calculator. But of course, even calculators have to follow some rules in making the calculations that they do. So how would this have been done? Well, what is 1.6? It is 16 divided by 10, because 16 divided by 10 is indeed 1.6. What's 16 divided by 10? Well, if we divide the top and the bottom by 2, we find out that that's 8 divided by 5. So 2.2 to the power of 1.6 is the same as, so it's equal to 2.2 to the power of 8 over 5. And that is simply 2.2 to the power of 8, the fifth root of that. So 2.2 to the power of 1.6 is 2.2 to the power of 8, and it's the fifth root. 2.2 to the power of 8. 2.2 to the power of 8 is equal to 2.2 times 2.2 times, I don't feel like writing them all out, times 2.2. We can write out the 2.2 8 times, and in between all those 2.2s we can put times signs. And what is that? What does that work out at? Well, again, using a calculator, because I'm nowhere near clever enough to work all that out quickly in my head, we find that all those 2.2s multiplied together work out at 548.76. That's a decimal. 548.76, and so 2.2 to the power of 8, the fifth root thereof, is equal to the fifth root of 548.76. And remember, that's simply to ask what number multiplied by itself 5 times gives 548.76, and we've already said up here that 3.53 does. 3.53, roughly, something like that. So we have 3.53 times 3.53 times 3.53. How many have we got there? 3. We need 2 more, times 3.53 times 3.53 equals about 548.76. 548.76, and I'm just going to confirm that using a calculator, and I find yes, indeed it does. Now, there's been some rounding, there's some other little digits that come after this 0.76 and after this 0.53, but that is roughly right. So 2.2 raised to the power of 1.6 is indeed equal to 3.53 or thereabouts.